Now, this was something I made many years ago. I worked in electronics, and we had a young student working with us, and I was talking about bows and he thought I was bullshitting. So I pointed this little bit of aluminium, scrap aluminium bar that was lying on the bench. Now I'd picked it up and flexed it, and I knew it wasn't soft alloy, it was high tensile aluminium alloy, and it was only about that long. I think that was it. So I said to him, I'll tell you what, I'll make that into a little bow, and every yard further than half the length of a football pitch it shoots, you buy me a beer. Every yard less, I'll buy you a beer. He said, oh, all right, go on then. So I made it into this tiny little crossbow. Now it looks weird like that, but it's just like that so it can fit under your jacket. To shoot it, you actually rotate the prod like that. And to minimise the size of it, the trigger's quite nice because it's a basic trigger mechanism with the usual rotating nut, but it links to the trigger via a sliding bar. So as the trigger's pulled, it pulls the sliding bar forward, which releases the trigger mechanism. I'll dismantle it so you can see that. And I normally shoot tiny little bolts like this with the feathers offset to spin it and a bit of wire around the end to give it some weight, but they're actually a bit dangerous because they can bounce back out the target. So I thought, I know, I'll turn some nice little pointed brass points and make some pretty little bolts just for the fun of it. There's very little power in it. I mean, you can turn it around and shoot yourself in the belly. As long as you've got a thick sweater on, it doesn't even hurt. But it's got quite a lot of velocity, and yes, it did shoot further than half the length of a football pitch, but I let him off the beer. Anyhow, I'll dismantle that and show you how the trigger works, because it needs a bit of cleaning up. This bolt clip's all loose, and I thought I'd just tidy it up for something to do. That and make some bolts. Here we are, here are the component parts of the trigger mechanism. It also shows how the prod screws into a nut. As the trigger pivots, as the trigger pulls back, it pulls that bar forward out of the little groove that allows the nut to rotate. Surfaces are hardened, and that's it. To keep the bar moving smoothly, there's a couple of steel pins going through the stock. There we are, a couple of steel pins that go through, so you can see the steel bar goes in like that underneath that, those two steel pins. So a very simple mechanism, but it just keeps it very small. You've got the trigger at the front and the actual latch right at the back. The prod just screws into this bit of steel with a threaded hole in it. Threaded bar that slots into the stock like that. Little return spring. Little return spring there for the trigger. So what I'll do is I'll just clean it all up, and I'll sort out this bolt clip and make some pretty little bolts for it. Yeah, so I've put the trigger and the bar back in, so that's in the position it would be having just shot. And if I pull the latch back, you'll see the bar slide. You hear it click into position. So that's now cocked. And as I pull the trigger, you'll see it slides the bar forwards, enabling the latch to drop. There you go. Now I've made a nice little bolt with a brass tip and two fletchings. So let's try that. cocked and ready to go. Shot rather high, not quite sure why. I'll have another shot. The bolt was definitely flying high, so I adjusted the fletchings, so you can see there, now at a bit of an angle to give it more spin. I was hoping the natural curve of the feather would give enough spin. In fact, you often see discussion on archery forums about offsetting feathers to give better stability and all the rest of it. Normally it's not necessary, because you can see a feather has some natural curve in that direction, but you'll also see the vane itself. Where would if the camera would focus? The actual veins themselves are curved. Not only that, but they're smooth on one face and sort of rough on the other. So that should give, that natural asymmetry would impart spin anyway. So normally angling the flights isn't necessary if you've got 3 of them, but with 2, obviously it can act like a wing, so a bit of offset's necessary. They do say that with broadhead points, like in America and some parts of Europe where they hunt, you need some offset to get it to spin, because the flat blade of the broadhead can make the arrow plain. Anyway, with 2 fletchings, I've put them on the skew like that to make it spin. And here we go again. It's not actually that easy to aim through a camera. Still looks a bit high. But you can certainly see it has rotated, because the fletchings are now, at that angle, whereas they started off like that. I'll try a longer range shot. Oop. Right, it's difficult to aim, because if I look at it like that, I'm actually pointing up. If I look along the edge of the stock like that. No, still high. Oh well, draw your own conclusions. Maybe it just shows I've got no idea what I'm talking about. Or maybe it needs an even more aggressive kick up on the back of the bolt. See, on this one, on the paper ones, I actually bent the the trailing edge right up to make it spin. In fact, I'll shoot that. I'll kick the back edge of that up and see how it goes. Right, paper fletched bolts with the trailing edges kicked up severely. Now this might bounce back and hit me in the face, but we'll see. Yeah, bounced back. Which shows why I started the project in the first place. Anyway, maybe I'll resort to, I don't know, the camera might show where that struck, but I've got parchment, I could make parchment or paper flights or whatever. That's enough for now, else I'm in danger of turning it into my life's work.